Hey, what's up everybody? In this video tutorial, we're going to be taking a look at how to create a parametric snail cam. This is definitely going to be the most difficult one out of the group. The thing is, there's something out there called equation curve, and it's going to be really helping us out a lot with this one. We've seen this one done many different ways, and just very messy because there's lots of tangent constraints and things that you have to apply to it. But we can use the math to help drive the profile that we're looking for. And when you take a look at a snail cam, we can see it's going to gradually increase, okay, in 360 degrees. So we're starting out with the least radial dimension here, which is going to be a quarter of the diameter, and eventually it's going to increase gradually until where it goes out to half the diameter. All right, so we're going to be using the equation curve to do that for us. We're looking at all sorts of different variables here. We do have some static dimensions. We'll be applying all those in parameters with Inventor. And let's go ahead and get started with that right now. So just have this cam dimension drawing in front of you. It's going to be sort of making sense maybe of what I'm kind of doing with this. All right, so the first thing I'm going to do is come out, go to Manage, go into my parameters, and then I'm going to start loading in some user parameters. So I'm going to add a numeric, and I'm going to call this one DIA for diameter. And my equation, this is just simply a number. It's going to be a placeholder right now, but the smallest, snail cam we're going to have is 1.5 inches for our nominal diameter. Okay, so I'm going to go ahead and add a numeric, and this time we're going to add whole. Okay, and then for whole, our axle that we're using, the axle size that we're using for our pole toy is going to be an axle of 0.25. So we're going to go ahead and plug that in. And then finally, our last numeric that we're going to add is going to be THK for thickness. And I just simply come in here and put in our plywood thickness, which is 0.1875 or 3/16. Okay, so we're all set and ready to go. So I'm going to go ahead and hit done. I'm going to go into my 3D model environment, start a 2D sketch, and I'm going to be picking on a plane. All right, so the first thing we're going to do is we're going to come up here to this guy right here. This is a construction line. We're going to go ahead and pick on construction line, and we're going to draw a circle, okay, starting from the origin. Okay, we're going to be bringing this out. So as I'm doing this, I'm going to go ahead and right click, and I'm going to switch this over to a radial dimension. All right, so the radial dimension I'm going to be using at first is going to be half of our diameter. So I'm just going to type in DIA. We're going to multiply that by 0.5. Okay, and we can see it's a construction line. It's going to be that dashed line. This is going to have no impact on the actual part itself. It's totally cosmetic. It's just something to help us get things started. Okay, we're now going to come up here, go to circle, go start back at our origin. We're still on construction line, but this time we're going to be typing in DIA. We're going to be multiplying that by 0.25. Okay, so we're going to go with quarter of our diameter. All right, so we have those made. I'm going to be switching this back over from construction line to original line or regular line. Okay, and now we can go ahead and go into our next part. So underneath line over here, we can see something called equation curve. Okay, this looks a little bit confusing. I'm hoping I can explain what the heck this actually is. So what we're going to do first is switch this from Cartesian over to polar. Okay, the equation that we're going to be popping in on this is going to be, we're going to take the diameter, we're going to divide that by 4, and then we're going to be multiplying that by something called t. We're going to define what t is here in just a second. But the thing is, we want to add DIA divided by 4. All right, so basically what this equation is saying is we're going to start out at quarter of the diameter, okay, and at full 360 degrees, we're going to gradually increase this, okay, to the diameter divided by 2. All right, so it's basically splitting the difference, which is a quarter, and that's why we're seeing 4 divided twice in there. All right, so now we need to define what this is. So we're going to type in t, we're going to multiply that by 360 degrees. Okay, and as soon as we do that, we can see how it's going to create that object line, okay, going out in that snail form. Okay, I'm liking what I'm seeing here. I'm going to go ahead and green check it. All right, so we're starting from the center, we're going outwards. All right, it's just going to gradually increase it. So all we have to do now is come back in, go into line command, and construct our line from this endpoint to this endpoint. All right, we still need our axle hole right there at the center of this, so I'm going to go into circle. Okay, making sure that I'm switching this over to diameter because right now that's indicating that's radius. I need to right click, okay, come down, switch this to diameter, and all I have to do is type in hole. Okay, so it's going to load that parameter in. So now I'm going to finish the sketch up, go out here and do an extrude, pick our profile, make sure it is symmetrical in nature, and I'm just going to now type in THK for thickness. It's going to load that parameter in, and now we can say OK. All right, so I'm just going to pull this over to the side, go back into Manage, go into Parameters, and now I'm going to be switching this from 1.5 inches to 2. And then from 2, I'm going to be switching it over to 3. Okay, back down to our small setting, which is 1.5 inches. And let's just try 3/4 of an inch. Let's just see what it does. All right, so it is growing and shrinking according to the diameter that we're going in and changing on this. So I have 1.5 inches here. I can go ahead and hit done. All right, and if you want to quickly create like a part library, oh, just don't forget you do need to apply your materials. All right, so make sure you're looking at the project, seeing what material to apply to cams. But if we want to make a part library, here's how we can do it quickly. We can go ahead and do a save as. Okay, now we can come in, we can give it the name of Snail Cam, all right, and then just at the end of it, we can go ahead and just type in 1.5 for 1.5 inches. We can go ahead and do a save. Okay, now I can come out here, go to Manage, go into Parameters, switch this up to a 2-inch diameter, say Done. Now we can go ahead and do a save as. Okay, I can come out here now and find my Snail Cam, add 20 to the end of it for 2 inches and do a save. Okay, and then finally we can come up here, go to Manage, Parameters, change this from a 2 to a 3 inch. Okay, we can do Done. Okay, and now we can finally go ahead and do a save as, and now this time we can change this from this to 3.0 for a 3-inch snail cam. Okay, so just that fast, we've just come up with 3 different sizes of snail cams. They're absolutely perfect according to that equation curve. Now you have those parts for a part library in case you want to swap those out and use it. Obviously, if you place this into an assembly, you can always change those parameters on the fly. You can adjust the size of this. So there you go. That's how you create a parametric snail cam for the Pole Toy project.